All right, good afternoon, everybody. I appreciate you coming out. My name is Nate Delgado, software product lead at SealingTech. And I'm going to talk about a little bit of the history of Operator X, give you kind of a behind the scenes look at the latest and greatest technology in the SealingTech product portfolio. So let's jump in. If you're not familiar, SealingTech is a leading provider of cyber flyaway kits, basically powerful edge computing devices and defensive cybersecurity solutions, mostly for kind of the flyaway kit use case, the CPT use case. Really, I like to think of them as a data center that you can bring with you on an airplane. Everything that we make here in our hardware portfolio fits in carry-on luggage. You can actually maintain positive control over your hardware while you take it with you. That includes high compute nodes, that includes high storage nodes, that includes AI and ML nodes for GPU workloads at the edge. All of this is fitting in custom 3U cases, like I said, that fit in carry-on luggage. So you can take those anywhere with you and maintain security over your assets. As we kind of look into what drove the solution Operator X, I want to highlight a couple of challenges that the modern warfighter faces, right? And all of this has to do with complexity. That includes tool sprawl and the increasing number of tools that have different syntaxes and different interfaces, different ways of administering them, and the administrative burden that comes with running these tools, right? That's things like writing reports, right? Everyone hates writing reports. Also includes system engineering tasks that not everyone's going to be familiar with. That's things like standing up your virtual infrastructure, that's setting up your network. That's all the other pieces that aren't even just threat hunting that not everyone is going to have fully sufficient training or fully sufficient expertise in doing. And we see this all the time, right? Where the junior operators are really maybe helpful in the things that they're really comfortable in, but the stuff that they're not as familiar with, they need the help. And we see this as a force multiplier that turns your junior operators into senior operators through the power of this AI platform. Also, just across DoD, it's not super easy to adopt AI, right? For one, a lot of the more powerful models are exclusively available on the internet. And so in the air-gapped environments, there's just not much you can do unless you're going to run like the kind of weakest models on just some individual laptop or something. And if you are going to use the more powerful models, there's risks of data spillage, right? And you're sending that data to who knows where. And that's not really tenable for most missions unless you're going to, I mean, we've heard stories of people that are leaving the secured area and going and using ChatGPT from the parking lot, right, on their cell phone. And that's not a great way of doing it either. So we want to be able to help the warfighter with all the challenges they're facing, while also allow DoD to adopt AI in a safe and responsible way. And so that brings us to Operator X, our solution. Really, it's built on three core components of modern AI technology. That's RAG, Retrieval-Augmented Generation. This provides the knowledge base that is actually tuned to your data and your information. That's the LLM, the large language model, that provides the intelligence for combining your knowledge with actually allowing you to take action using the custom agents that we've created that tie it all together. And so these three components make up one AI platform that is your data and the intelligence of the LLM, allowing you to actually command your arsenal and interact with, integrate, and control the common security tools that are available on flyaway kits and really for any DCO missions. So I want to walk you through a little bit of the history here. We started with wanting to design this around the best, right? And so at the time that we started this last year, we were looking at some of the models from Llama, including one of their more powerful ones, the 3.370B model. This is a great model, but if you want to be able to use the full power and not quantize it too deeply, you're going to need a powerful GPU. And so we also started with the NVIDIA H100, which is an amazing GPU, but it's one of the more expensive and hard to get cards on the planet right now. And so in listening to customers talking about this, we heard the same things over and over again. This was too expensive and too big, right? Despite it fitting in our standard 3U cases, it really meant taking an entire separate server case with you, which in many cases is untenable when you already don't have enough room for all your current equipment, right? And so this meant going back to the drawing board and coming up with a new and improved Operator X that really meets the customers where they are. And so that's what I want to talk about today. This new version includes more agents, more integrations, more intelligence, and overall more capabilities, while also being faster. But you might be wondering, what does all that stuff have to do with making it smaller and making it cheaper? Well, that's why I'm excited to announce that now, with the pace of AI innovation here, the definition of best is constantly changing. And so this new version is optimized to run entirely on a laptop like this. So that means no more of the NVIDIA H100. Actually, it's optimized for the NVIDIA Blackwell 2.0 architecture that is now available on laptops like the one I just showed. And it also means new models, with the one we're using right now being Mistral Small 3.1 24B. So really, we've kind of redesigned the entire thing from the ground up, and the rest of the presentation will be walking you through how we got there. So when we wanted to make sure this was available in a smaller form factor, it really meant essentially a Goldilocks problem, right? There are a ton of really big models, there are a ton of really small models. If you have the full 80 gigabytes of VRAM to work with, like in an H100, almost anything is possible. But if you're in a limited VRAM scenario, you have to make sure you find something that's optimized for that. And so you go too small, and of course, things start getting pretty dumb, right? You start getting models that, especially if you start quantizing, right? You get models that almost are pretending to be smart. They act as if they're lobotomized. And you go too big, it means you have no room for context or KV cache. And for our architecture, where we have complicated prompts that have sometimes even up to 4,000 tokens in a single prompt, you need to make sure to leave sufficient room for context and the user's query so that you're not taking up all the VRAM just with the model itself. So we needed to find a model that really fit right in the middle of this, not too big, not too small. And so to do that, we wanted a way to quickly and effectively test a whole bunch of models in real world scenarios that mirror our use case. And so this meant actually building our own evaluation pipeline, which is essentially a collection of benchmarks around running it through our prompt foo evaluations, running it through our RAG pipeline, testing it on cyber domain knowledge, and tests like the needle in the haystack problem, where if you give it a bunch of context, like a really big prompt, is it able to extract details from right in the middle of that prompt? And also following instructions versus models that are more tuned for just chatting back and forth, right? So this meant looking at over 40 total models, and out of that 40, only 16 were able to even start this pipeline for various reasons, whether they didn't fit or had some other issue with parts of the benchmarks here. And of the 16, only 9 of those were able to actually finish the pipeline. So out of that 9, I can show you some data here. We'll go over it briefly. There's a lot of stuff on the screen here. I'll just kind of speak to a few pieces. On the left of these charts, you'll see the sort of teal color. That is the original Llama model. And you'll notice in that first chart in the upper left, it actually is one of the worst performing in some of the domain knowledge tested through the computer science benchmark that we have here, right? And also, it is pretty damn slow. If you look at the bottom left two here, sequential token speed and batch token speed, the Llama model is one of the worst in speed as well. And to kind of get a preview, the sort of very light green bar that's on the far right of every chart here, that represents the new Mistral model that we ended up switching to. And not only does it rock the computer science domain one, it actually is holding its own in pretty much every single test here. And it's, I think, in most cases, the second or third fastest one as well. So we knew we were actually on the right track when we started seeing models like that. The next one I want to show is just head-to-head, right? This is the Llama model running on full 80 gigabytes of VRAM versus Mistral on a card with only 24 gigabytes of VRAM. And it's interesting here, you see some of the same things that we were seeing in the previous one, but one thing I want to point out is how much faster the Mistral model is, despite being on a weaker card, right? You see the average first time chart, which is the third one on the top. That's the one chart here where lower is better, and the the green one on the right, Mistral, ends up smoking Llama in that, as well as for the sequential and batch speeds, it's much faster. And this is, like I said, despite being on a less powerful card. And then we're talking about the intelligence. Yeah, it's much better in domain knowledge measured through the computer science test. And it also is just barely behind Llama in a couple of other tests, and also ahead of it in many others. So when we saw that we would just lose marginal amounts of accuracy here, but then get so much more in speed and domain knowledge, it was a no-brainer to end up switching to this. There's a few other reasons why as well that I'll get into later in the presentation. But switching models meant actually a handful of problems. And the main one I want to highlight here is how it broke our LoRA architecture, right? So previously to this, the architecture for our agents was all based around LoRAs. That's low rank adaptation. Essentially, it's a way for developing high accuracy in a model by fine tuning it on custom data after it's been trained. And this is how we used to do things. All of our agents used to be running off of LoRAs, where we had custom data sets that were basically representative of all the different types of questions and workflows that our agents could perform. And we would train it on that and get really high accuracy in those types of tasks. The issue is LoRAs are explicitly trained on individual models. So the second you change the model, your LoRAs break, and you would have to actually retrain every single LoRA on every single agent to be able to keep doing that. So as we know that these models are constantly changing and we're wanting to make sure we're staying on top of the best models at all times, we realized that the LoRA architecture actually wasn't going to be feasible for our use case where we wanted to maintain that nimbleness. So the light bulb moment here was, how can we start something or change to an architecture that is essentially model agnostic? And that's where we came up with the idea of changing architecture to support reasoning. And reasoning is actually really similar to what you've probably seen a lot of the big providers do when you see ChatGPT or Gemini take a second to respond, and it will say like, give me a second, or thinking for a few seconds. That's reasoning, where it's essentially chatting with itself before giving you the final response. There's like a chain of prompts that it's evaluating and actually kind of concurring with itself as it's working through a workflow. And that's what we ended up adopting for our own architecture. And in doing so, building those prompt chains and building a workflow like that, we're able to hit accuracy that's just as good, if not better, than what the LoRAs had. But now we're essentially model agnostic and much more flexible than ever before. Yeah, this is more information on reasoning. What it looks like for us is essentially a decision tree, right? We're going to rephrase the user query. We're going to then determine the next steps to reach that goal, execute all the steps, and then translate that output into a final human-readable response. And we have some screenshots here of what it looks like actually in the platform, right? Walking you through the status of running through that decision tree and all the stuff it's doing behind the scenes to do those reasoning workflows. That includes pulling stuff from potentially individual tools via API, figuring out exactly what the user intended, making sure to compile all that, and finally give you the final output. As we're doing all this in general, it wasn't just looking at different models, right? We also tested other ways of trying to get this in a smaller footprint. So we looked at external GPU systems. This was definitely a really interesting solution that allows you to get full power, like a full kind of desktop GPU power, but it's also a little bit cumbersome, meaning that you would actually have to have a GPU sitting next to you on this laptop the whole time. We looked at CPU offloading. Again, anyone who's tried this will be able to tell you it's really slow no matter what you're doing, especially if you're using larger models. I mean, it can get really painfully slow. It allows you to not require as much VRAM, but it is the trade-off of, yeah, just being painfully slow in a lot of cases. And we tried a whole bunch of quantizations across the different models that we were evaluating. But like I mentioned before, you quantize too much and it basically loses its ability to actually be intelligent, right? I don't know if anyone's ever tried model quantized below around 4 bits, and like the way we describe it is it essentially is pretending that it's smart. It's actually really funny to watch what happens when you do this. It's not really workable for these types of scenarios. So at the same time that we were doing this sort of testing and evaluating this stuff, there's also advances in hardware. And so the latest Blackwell 2.0 architecture, which represents GPUs like the 5090M from NVIDIA, that GPU is now the first time that you can fit a full 24 gigabytes of VRAM on consumer-grade mobile hardware, like the laptop I showed us a few minutes ago. So kind of the combination of those things, the really powerful laptops and finding a model that could fit in that size means that we can now deploy the full version of the Operator X server in a laptop that just fits in a backpack, right? So that's why I call this version of it now the most flexible, portable, and extensible version of Operator X. The last thing I want to speak to here is how you can deploy it, right? We've been talking mostly around the CPT use case, where you're really doing it on the edge, where a laptop is kind of necessary. That's where we have a really simple way of licensing per instance, and that's going to then be supported with support and updates over the course of the life of the kit. But we're not limiting Operator X to exclusively SealingTech hardware. It's actually very simple to deploy this on-prem or in the cloud for a more enterprise deployment. And if that's one of your use cases, please come talk to us. We'd love to hear about it and get you set up with a trial. From there, I want to use my last few minutes here to actually give a demonstration of some of these latest features that are in this now officially released version of Operator X. That's going to be the image analysis, which is possible through the now multimodal model from Mistral, automated file ingestion, and automated reporting. So I'll go ahead and pull that up here. So I'm going to show you the automated file analysis. You can now add, or image analysis, you can now add images straight to individual chats. So I can show you that here. I have a network diagram. Can kind of show you what this looks like. Pretty simple network diagram, but this is exemplary of a problem that we hear a lot of CPTs face, where you're going to a network that you've never seen before, right? A network that you're totally unfamiliar with, and you might only have a diagram like this. Sometimes maybe even it's a sketch on a whiteboard or something that you need to parse and turn into an actual sensor deployment strategy, right? And so you can ask a question like, where should I put my network taps on this network? It's gonna analyze that image and immediately spit out essentially a strategy for you to follow, recommendations on where you could put that tap and actually help you out there. And what's cool about this too is that it's smart enough to read the host names out of that image, right? That's just a PNG file. It actually pulled out the host names of the individual routers and switches here. So it's pretty powerful on a per chat basis, being able to just upload any image you want and be able to ask it questions. I also wanted to show off the automated file ingestion. So in here I can go to settings and pull from SMB. So I'll just show one here, pull from a specific directory. And what this does, when I kick this off, it's going to immediately ingest. There we go. 6 files transferred from an SMB folder. We can now go to files and see those. There they are. There's our 6 files. The last 2 of them are still indexing. This should be done in just a couple seconds here. When those are done indexing, that's fully available now in the RAG pipeline, so that every single one of these things we just uploaded is now something Operator X is familiar with, and you can chat with it and interact with it, correlate it with all your other data coming in from other tools. And then the last one I wanted to show here is the automated reporting, right? I mentioned earlier how there's not anyone who enjoys writing reports. Well, we made sure to do something about that and now have an agent for writing reports. The one I'll show you right now is the kit usage report. So what this is going to do is kick off one of those workflows like I was talking about and pull data from multiple different external sources. That's going to pull from VMware, it's going to pull from Security Onion, and it's going to pull from Elastic, and turn that into a handful of backing evidence files. These are CSV files that'll show up in just a second here, and take that CSV data and then turn that into a nicely formatted kit usage report in Word form. And I can open that up real quick for us. Hold on, there we go. Sure enough, we have this really nicely formatted report that includes everything from VMware usage, host, CPU, virtual machines, like that, Security Onion, sensor usage, your Zeek and Suricata loss, and your information about your Elasticsearch indices. So this is just a small taste of a few of the new features in this latest version of Operator X. There's a lot more I haven't gone over that is that we've talked about in previous talks, as well as available for demos at our booth. If anyone wants to stop by, we are booth 121. We'll also be giving a demo, I think it's at 10:30 tomorrow at the booth. So if anyone wants to see that and get a full taste of it, I'll be at the booth afterwards, and I'm happy to show anyone any specifics or talk about your use case. With that, I'll open it up for questions. Thank you. Great question. I'll repeat the question. He said, yeah, in the demo I only transferred 6 files. What would it look like if there were thousands? Ultimately, this is going to come down to just your own network bandwidth. I mean, that same SMB share, if I had not done the specific directory, has like, I think, almost 200 files. That happens, the upload itself happens in just a second or two, and then the indexing follows a few seconds after that. So it's not going to be instantaneous, but it's also not going to take you that long. Anything else? Yeah, in the back? I'm sorry, I actually can't hear you super well. Yeah, great question. It was about what products this compares to in the market right now. From my perspective, there's really not much that's similar to this. There are, of course, a ton of competitors that are doing just offline LLMs in general, but pretty much I mean, they might have a RAG database and stuff like that, but in general, they're going to be for more generic use cases like business or analysis or strategic stuff like that. We're the only ones, to my knowledge, that are really focused on the defensive cyber use cases. So you see that in the types of models that we're choosing to make sure that we have models that are that contain enough domain knowledge to be effective here, as well as the custom agents that allow you to command the specific tools that are commonly used in DCO. So I think that's I think there's not much. I mean, that being said, of course you could use the big cloud provider models, but like I said earlier, those have a lot of their own risks as well. So we think we're really the only one that's doing exactly this right now. Anything else? Yeah, go ahead.
Images and videos?
Yeah, so the question was about can we generate images and videos? That's not currently supported. The model from Mistral is only able to read and analyze images versus actually generate them, but that's something we're looking at closely. We would love to have a model ultimately that is fully multimodal, that has all sorts of different use cases. Absolutely. Anything else? All right, well, thank you very much. I think we're over time. I appreciate it. Come by booth 121 if you want more of a demo. Thank you.